In this video, I will show you how to calculate a Pearson correlation. In this example, a researcher is interested in whether there is a relationship between exposure to violence as a child and that person's aggressive behavior as an adult. The data is below. Each variable has given a letter, X or Y. The level of exposure to violence of a child in this case is X and Y is aggressive behavior. The data is listed below. So each row represents a person's set of scores. So the first person, the level of exposure to violence as a child was 8, and the aggressive behavior as an adult for that same person is 14. So again, each row represents one individual. So then there's another person, their level of exposure to violence as a child was 7, and aggressive behavior as an adult was 13. Now the first step is to fill in this matrix, because let's look at the formula. First, we need to square our x's, so we need to do that. We also need to square our y's. We also need the sum of our x, y's multiplied. So for example, here, if we were to square x is 8, you get 64. Then we'll do the same thing for y. 14 squared will give us 196. Then we take x and multiply it by y for each individual, and in this case we'll get 112. We'll do the same thing for every individual. After we're done, we're going to add up our columns. So for example, for x, we add them up, it's 49. For y, we add them up, down the column, and it's 86. Now I'll show you a completed version. Okay, so here I've filled in the remainder of the matrix. Again, we simply went through, squared each x, did the same thing for each y, and then multiplied the xy for each individual. After we were done, we added up all the scores for each individual column. So here are squared values. We added them up. Here are squared values, which were also added up, and here we've multiplied each xy combo, and then the final step is to add up. So to find all the parts of our formula, we'll go ahead and type them in here. The first thing it's asking is how many people are in this study. And in this study, we had 8 people. We can see that by the number of rows. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 people in our study. Then we need to find the sum of x. That's already included in the table. It's 49. It's right here. The next one is telling us to sum x first and then square it. That's the same as saying 49 squared. So we'll do that next. So 49 squared gives us 2,401. Then we'll need the sum of our squared x's. So this is where you square them first and then add them up. It takes us to 315. The sum of our y is 86. Then we'll take this number 86 and square it. So this is 86 squared. And 86 squared gives us 7,396. Then we'll find the sum of all our squared y's, which is 956. That's when you square them first, then add them up. And then the sum of all our xy combos, so that's 545, and that was found right here in our table. Okay, now that we have all of the numbers that we need, we can go ahead and include them in our formula. So our formula is here. And we can go ahead and start to fill in the numbers from our data matrix. Okay, so let's look at the numerator for our formula. We'll start with n, which is here. That was 8. We had 8 people in our study. The sum of xy, which we found was here, 545, minus the sum of x, which was here, 49, times the sum of y, which was here, was 86. We're ready for our denominator, just filling it in. N, again, was 8. The sum of our squared x's. Now this is where you square it first, then add it up. And that one is here. So that's 315 minus the one in which we added up and then squared it. And that value is 2,401. All right, we're going to do the same thing for y. It's 8, that's our n size. The sum of our squared y's was 956 minus the sum of y squared, which was 7,396. All right, now it's a matter of just computing the values in our formula. So let's start by the multiplication. So 8 times 545 is 4,360. 49 times 86 is 4,214. 8 times 315 is 2,520. And 8 times 956 is 7,648. Our next step will be the subtraction. So let's move down here. R equals, here we have subtraction for the numerator. So 4,360 minus 4,214, and that is 146. And that's for our numerator. Now we have subtraction here. So 2520 minus 2401. Don't forget that square root sign as we're moving along. And that gives us 119. Then we have 7648 minus 7396. And that gives us 252. Just a couple more steps and we'll be all done. Here we have multiplication. 119 times 252 is 29,988. We'll take the square root of that number. Just move the numerator, so it gives us a place to put that. Remember, you have this square root sign, so don't forget that part. It's 173.17. Okay, for our final step, it's 0.84. So to write this up in APA style, the reporting of the results, the degrees of freedom is always degrees of freedom equals n minus 2. N was 8, so our degrees of freedom is 6. Equals 0.84. This is a strong positive correlation. We'll have to look up a table of critical values in the back of the book to see if it's significant. At a degrees of freedom of 6, if you look it up in the back of your book, it is statistically significant. And R squared, our measure of practical significance, is 0.71. So we'll say it has strong practical significance.